Hi everybody. So the next section we want to look at here is section 7.2, and this is on applications of the normal distribution. So in the last section we looked at a couple different distributions, the uniform distribution and the normal distribution. In this case we'll mainly concentrate on the normal distribution. So let's look at the objectives in this section. So there will only be two in this case. We want to find and interpret the area underneath the normal curve, and then find the value of a normal random variable. And so these will kind of be opposites of each other, but let's look at objective one. So let's say we want to find and interpret the area under a normal curve. So we kind of did this back before in one of the previous sections, right? So what you want to do to calculate the area is first of all calculate the z-score. And so the z-score can be calculated by this. You take your score minus the mean over the standard deviation. Right. In this case, you can assume that we're dealing with the standard normal curve, which means the mean is 0 and the standard deviation is 1. And then based on that, we can calculate the area. So let's look at an example here. So let's say IQs can be modeled by a normal distribution with a mean of 100 and a standard deviation of 15. So just go ahead and calculate the z-score, right, by doing this. And then again, you can just look that up in the standard normal table. You don't have to worry about the mean and the standard deviation as being different in this case. So so just look up, so our value for the z-score is about 1.33. So look that up in the table or use StatCrunch, and you get that the area to the left of that point is 0.9082. And remember, the area underneath the standard normal curve is 1, so that should encompass most of the area underneath the curve. Maybe just to show you that in StatCrunch here quick, if we do go to StatCrunch, right, if I put in an area here, I put in a z-score of 1.33, right, you should see that gives you most of the area, and that does give you the area there. So remember, this is the area or the probability of an event, of that event happening, right? So I guess another way you could think about that is you have a 90.82% chance that the IQ scores would be less than 120, right? Because a 120 IQ is relatively high. And then if you wanted to find the area to the right of that, you could take 1 minus the area, and that would give you the percentage of people that have IQs over 120, which is only about 9.18%. And then just remember that remember the empirical rule, right? So that about 64% of the data is between 1 standard deviation, right? 95% is between 2, and 99.7 is between 3 standard deviations. Let's say, for example, that we want to find the area under the normal curve to the left of z is equal to negative 0.38. So what you would do is just go to negative 0.38 on your curve, and again, remember in the table 5 does give you the area to the left. And again, you could use StatCrunch to give you the area to the right if you want, but that would give you the area there. Let's say that you wanted to find the area under the normal curve to the right of 1.25. So again, remember, if you're using the table in your book, this is the area to the left. So if you want to find the area to the right, you'll have to take 1 minus 0.894. Right? Let's say you want to find the area underneath the standard curve between a z-score of negative 1.02 and z of 2.94. So what you'd have to do is find the area to the left of 2.94 and subtract the area to the left of negative 1.02. Right, so if you look those areas up, you'll get that, and then just subtract, and that should give you the area between the two. So generally, if you want to find the area to the left of x, right, the area between x and x of 1, basically, sorry, let me back up here a little bit. If you want to find the area to the left, you just look up the value in the table, right? If you want to find the area to the right, you have to take 1 minus the area. And then if you want to find the area between two x values, you want to subtract the area to the left of z2 minus the area to the right of z1, as we saw in the example. So that brings us to objective 2, which is to find the value of a normal random variable. So basically we want to draw the normal curve and shade the area corresponding to proportion or probability or percentile. Again, you don't have to do this. And then use table 5 or StatCrunch to find the z-score that corresponds to the shaded area, and then obtain the normal value from the formula x equals mu plus z times sigma. So essentially what we're doing is the reverse of what we did before, right? We're looking up probabilities or percentiles, and now we're doing the reverse. So the question is, what is the score of a student whose percentile rank is at the 0.85th percentile, or 0.85 percentile? That means that the area underneath the curve is 0.85, or the area to the left of the x value you're looking for is 0.85. So find the corresponding z-score for 0.85, which is 1.04. Either do that with table 5 or StatCrunch. And then just take the mean plus the z-score times the standard deviation, and that will give you the x value. Right? So a person who scores 1246 on the GRE would rank in the 85th percentile, meaning that 85% of the people who took the GRE did worse than that person, right? And 15% did better. Let's look at another example here. So let's say that the length of a certain steel rod is normally distributed with a mean of 100 centimeters. So it's normally 100 centimeters long, and it has a standard deviation of 0.45 centimeters. Suppose the manufacturer wants to accept 90% of all rods manufactured. Determine the length of rods that make up the middle 90% of all the steel rods manufactured. So here we're looking at the middle 90%, so that means we have 0.05 on each end, so which would correspond to a z-score of negative 1.645 on the left, and a z-score of 1.645 on the right, because we're symmetric. So then x sub 1 would be 100 plus negative 1.645 times 0.05. That would give you the value on the low end, and then on the high end you would add, and that would give you 100 at 0.74 centimeters. So the person would want to accept steel rods between 99.26 centimeters and 100.74 centimeters. So one other thing here that can be kind of confusing, there is a notation here called z sub alpha, where alpha is basically the area to the right of the curve. So remember, normally in the table 5, it gives you the area to the left. But the z alpha score, you're basically looking at the area to the right of your alpha score. So you might have to take 1 minus that value, so that can be a little bit confusing. Okay, so that wraps up section 7.2. Remember, 7.3 and 7.4 are optional extra credit questions, so you don't have to do those unless you want to. But all right, so hopefully that makes sense. If you guys have questions about anything or anything else, just let me know.